of biological phenomena by looking at the just a second. I still hope that you hear me. Can you confirm? Yes. Very good. Where we were looking at an atomic phenomenon and being able to understand macroscopic influences. For example, here you see on the top in the middle, you see the actin filaments, where the structure at the macroscopic level was determined using electron cryomicroscopy and 3D tomography, which then was combined with atomic level detail from X-ray crystallography. So two methods that provide complementary information and allowed us to arrive at atomic level conclusions. We did the similar thing with not the nuclear pore complex, with porin, very complex at the time, where we were able to do atomic interpretations or macroscopic interpretations of atomic detail. And the only way to do that was by bringing together the output of multiple different sciences. Now, with those experiences, we ventured out into other industries back at the time and learned that this kind of collaboration is really benefiting a lot from the phenomenon of immersion itself. We all know that a couple of years ago, we were hit by the wave of these virtual reality glasses. Most people don't realize that a number of industries have been using immersion very effectively, both in research as well as in commercial environments, and to a certain extent also in education, in order to use the human brain's capability to visually understand better what's going on. So you'll see a couple of examples now that are taken from other industries. This in particular is taken from the building and construction industry. We always jokingly said that group immersion can be founded on virtual reality without glasses. You literally see here a group of individuals in a meeting room where the immersion is obtained by projecting onto walls. It's a concept that is being used in some industries today, not in molecular science to my knowledge, but I think it should. And the idea was really pioneered in the oil and gas industry, where very complex, multi-scale, multidisciplinary information needed to be visually understood in order to come to, in that particular case, commercially relevant decisions as to where to drill for oil, etc. This example you see here is literally how these visualization rooms that had immersive group capabilities were looking like back then. Some of these were so successful that actually the way humans understand visual phenomena could be measurably quantified by a factor of up to 5x in terms of making predictions based on the visual analysis of that. When we know how complex that molecular structures and biological structural phenomena are, any help that we can use to understand better what we're looking at that's happening in 3D is, of course, very welcome. You see today's version of this, these classic visualization rooms from the 90s, they were expensive. They costed multi-million dollars each one. Today, it's possible to install these at much lower cost. And in this particular case here, you see an example from the High School of Lucerne in Switzerland, which is using such an immersive screen to actually teach immersive scenarios to entire classrooms of 30 or 40 people or so. And I can only imagine when we would be able to introduce this kind of teaching aid by using molecular graphics. I think this would be greatly beneficial. Now, one thing has to be focused on in order to make something like this possible. When we talk about integrating multiple data sources to come up with new levels of scientific responses, it's really essential to focus on the scalability of the visualization tools themselves. We tend to create tools that are focused on solving one particular problem and doing that really well. But that usually precludes integration from happening, bringing different sources of information together, because they all require their own visualization tools, so to speak. And in a way, not having a kind of scalability that we can throw all information about a particular topic from all different disciplines together does limit the science, because we can only ever ask the questions that the tools that we use and have created are permitting us. And that is, in my view, really the next step of what needs to happen, and where we can also draw from lessons learned from other industries, like the geographic information systems in conjunction with what the building and construction industry does. You see here an example. The project that we're focusing on is this bridge here in the foreground, where for the first time, and this is, by the way, running in a web browser, so it's not even using a high-end gaming engine or something, but it's really using everyday's technology. You can visualize every single aspect of the local phenomenon, including the global environment. You see even here the Swiss Alps in the distance, and could, as an example of a use case, analyze how one particular building project would impact the view for certain individuals that are living in the vicinity. Now, in biology, we have similar problems. The structural questions that we try to answer, they have their impact at a macroscopic scale that is far beyond the atomic detail that we're investigating. So by improving and evolving software to the extent that it can span easily multiple disciplines and multiple orders of magnitude, I'm very convinced that we will be able to find new answers to scientific problems. Case in point, just two examples to highlight what I want to get at. Here's a publication from this year from the University of Geneva about the human centriole, where multiple levels of structures have been integrated. And of course, on the right-hand side, someone who has really influenced my own career many, many years ago, together with Art Olson from Scripps, David Gotzel. We all know his wonderful illustrations, but that's really what I'm trying to get at. We want to be able to visualize atomic level detail in a macroscopic context, make it easy for everyone to understand what's going on, regardless of what discipline and what level of detail. And in conclusion, I believe open source ecosystems are really key to making it possible to develop the next generation of scientific tooling, because not all the things that we do have a commercial relevance right from the first get-go. So being able to work with a community of scientists that work towards a more integrated, multidisciplinary approach, I solidly believe this is the way to go forward. Thank you very much for your attention, and if you have questions, I'd be happy to answer them.
Thanks, Chris. That was a very nice talk. Any questions? We have time for one. So while people are thinking, Chris, that your presentation reminded me many years ago at San Diego Supercomputing Center, they tried to create an immersive room for molecular modeling.
Yes.
And I don't know where that project went, but we haven't heard about it since. So I think that's why the title of this session being Back to the Future, I think is highly pertinent as we get to that future. All right. So looks like we don't have any questions. So thanks, Chris, for your time.
Thank you very much.
Thank you, Chris. It was a tough